good. Just trying to make things work out. I got invited to do a show in Corey Holford at the end of May, so been like going to the studio every night and painting
Hmm.
and just working on stuff. And then I was talking to Eric about the possibility of doing something in August.
Oh, we're online.
But
Yeah, we're online.
we're still figuring that out.
Oh,
So, but in yourself, I heard that your idea has gone into testing
Yes. Well, we should introduce who we have first.
for sure.
You have tuned in to. I'm just kidding.
Welcome to Robot and the Bear, episode
52.
52.
And we have Gerald Pao from the Salk Institute. You're a microbiologist, is that right?
well, I'm more. Well, I'm a number of things, but yeah, I was a virologist for many years.
Oh, virologist. Sorry. Yeah, that's even more. That's even better. So, you have a COVID-19 treatment and vaccine, I guess, or vaccine. Is it both? In
Well,
testing
it's
right
actually
now.
kind of both. Yeah, we're working on it. It's a nice sort of unconventional, so kind of a backup more than anything else. It's like it's a sort of a newish technology, um, where you
So, like, explain it for us, some plebes who don't know science.
Yes.
I actually did.
uh,
I got a D in chemistry, so I'm bad. D, literally a D. Yeah, yeah,
Wow.
yeah,
that's why you studied something else in UCLA.
yeah. I got a D in chemistry, and I didn't even redo it. I was like, you know what? Screw it, and I actually just left it on my record. Yep.
I think I got a C in chemistry.
Hmm.
Yeah, yeah.
Well,
We're not good at it.
but anyway,
Sorry.
so yeah, so
But now you know. But now you know what you're up against.
Yes.
yeah,
Yes.
I mean,
Yeah,
so
a D, and a C.
D.
That's pretty bad.
Yeah.
I got a D. So
Yep.
so yeah,
Sorry.
we're gonna talk about chemistry, so it's kind of okay. We'll talk about biology and medicine maybe.
Isn't it the same thing? Because I didn't do well in biology
Yeah, I
either.
didn't do well on that either.
I
But
got a
cool.
C.
It's cool.
Okay, well, I mean, it's still understandable. So,
Okay.
so yeah, so we're making we're trying to make these memory cells so your immune system remembers what it has seen before, and that's the basis of your most of your vaccines. That you inject something, you have a disease, your immune system then afterwards remembers what was there before. But
Mhm.
depending on the type of disease, it remembers more or less. So we're trying to directly tap into that and then train the immune system to have cells that remember stuff without ever being exposed to it. So normally a vaccine is basically like you give the same thing that the virus or bacteria is made of, and then it's basically you make a fake disease, but it doesn't actually reproduce in your body. So then, or reproduces very little. So then it's like then you get that memory without actually having the disease. So I'm actually, instead of doing that, I'm going directly to the cells that remember and then turning them on and says, okay, you should remember this. And we do it with this type of gene therapy kind of approach instead of giving a sort of a fake virus. So,
And you were able to produce positive results in the laboratory.
well, yeah, it's like, so we made it makes the stuff that it's supposed to make, and now we're testing whether it's like it works specifically for it. If it recognizes the way we imagine it would recognize it, and so that's what we're trying to make now.
So you actually make this, and you don't exactly test it first on any human being, not even once.
No, we first make it, and then it's like, I mean, I cannot test it on people.
Would you test it on like animals or
No,
anything first?
I test it mostly on cells right now.
Oh, I see.
Yeah, on human cells.
Oh, okay.
And it's
Mm.
basically like I put I put like some SARS-CoV-2 gene. That's the gene that is like the SARS-CoV-2 makes on some human cells, and then I'm making these engineered cells, and they're supposed to hunt those cells down, and then see if they hunt those cells down. So basically, that's what I'm trying to do.
Mm.
Like, if they can they find it, and can they actually get rid of the cells that are producing the virus? So
Mm.
this is so-called cell-mediated immunity. They're not antibodies. Antibodies are just the proteins that bind up stuff. But
Right.
there are actually other types of immunity called cell-mediated immunity. These cells go and they're kind of like the policeman and goes hunt down the cells that are producing. It's like shutting down meth labs, kind of like that.
Oh.
Ah, you're speaking my language. I think I knew a little something about that back in my day.
Yeah. So anyway, so it just goes basically on the surface of the cell and see, okay, if there's something in there that doesn't look right, and if something doesn't look right, the cells go in and basically kill the cell. It's basically like you just go and just bomb it, in the cell.
really?
With everything.
Sounds cool. Like a video game.
It's
Right,
kind of
right.
like that. Yeah, it's like it's like immunological video game.
So wait, hold. I'm trying to like picture this. So you have cells that have this, memory switch turned on, floating around. Then you have other cells that are getting infected by the COVID.
So yeah, so you want to catch it when it's early. So basically, like you go around, and let's say you breathe in a droplet. Somebody coughed, and then there's this droplet out there, and it goes in. You breathe it in. It goes into your lung, and then when it goes into the lung, it starts making, goes inside the cell of the lung and starts making virus.
Right.
But as it makes virus, there's a whole bunch of components it makes. So the components, they're like, some of them get exposed outside in the cell. So one of these components that the virus actually has, I'm making these, let's call it like these, they call cytotoxic T lymphocytes, or memory T cells. So it doesn't matter. But it's like these guys that go hunt the other guy, hunt the bad guys down. So I just engineer these cells. What?
They hunt down the T cells, or no? The T cells are.
Well, it's actually a little more complicated. I'm trying to simplify this thing, but it's actually is a little bit more complicated.
You could say you could use the words good and bad. I think that's the level we're at here.
Well, it's more like these. Okay, these cells that are
good.
That I engineer. They actually specifically recognize
helper cells. Okay.
Cells, yes.
Well, they're not helper, because helpers is a particular type of cell. This is not a.
Okay.
Oh, I accidentally got lucky right there.
You got into the lingo, but
wow,
that's
I got lucky. That was an accident. Okay, the helpful cells. How about that?
Oh, they're okay. You can call them like you turn on these memory cells, and then when you turn on these memory cells, then you actually make them killer T cells. So they're killer cells that go and kill off the infected cells.
Gotcha.
So now it's like, but I think there's how do they recognize the infected cells? So I put something in there. I added a gene into them that allows them to recognize the virus. So I'm engineering the cells so they actually can recognize the virus, and then just go and take care of it like that. So that otherwise, normally those cells would just be hanging around, not doing very much, just hanging around. But when they actually see some cells infected with virus, they reproduce a lot, and they all kill off the cells that are producing the virus.
And I guess in your lab you saw it kind of work.
Yeah, that's what I'm working on. Yeah, so we actually make it so it's making all the components, and then we're actually putting in. We're making these mock infected cells.
But that's the one that's in testing now.
Yeah, that's in testing. Yeah.
Wow. So have you heard any results on that, or how does that work at this point?
Well, I have to do it.
You have to do it?
Or Junko has to do it. Yeah, exactly. Yeah, we have to do it.
Oh, I thought the testing meant you send it to somewhere else and they deal with it.
We're doing all the testing also.
Oh, you do your own testing.
Is end to end, kind of, until you give it off to and it says, okay, this is more or less is actually, I think this is a pretty good shot. It's work, all the basic things are working. Maybe we have to partner up with some company that can produce like human grade stuff, and then they will do some more.
So how do you feel about it this far?
Well, so far everything is working, but it's like, I mean, it's gonna be like sort of the reason we started this is because we're not sure that the conventional vaccines that everybody's trying right now are gonna.
There's like 100, isn't there? I thought I read that there's like 100 vaccines,
like 60 lead things, and there's hundreds. Actually, I don't even know how many there are. There are like tons of people trying at different stages. So there's like two of them that have actually gone into people, as far as I know. One in the UK, and one in the Seattle area.
Oh.
What are those called? Do you know what they're called?
Well, one is from a company called Moderna.
Oh, is that the one that we've been hearing about, Remdesivir or whatever it's called?
No. That's a treatment. That's a drug treatment.
Oh, I see.
Remdesivir is a drug treatment. It's not a vaccine. The vaccine is made by this company called Moderna. They make this basically this RNA, package it inside these fat droplets that kind of imitate kind of cells. It's like they're called like lipid nanoparticles. Sounds fancy, but it's basically a little fat droplet that's hollow inside, and inside you have some genetic material. And when it goes into the cells, it makes the same thing that I'm making, the target that I'm making, this so-called spike protein, the spike protein of the virus. And then when you make the spike protein of the virus, you teach the immune system to attack the spike protein of the virus. And then, then you hope that you're going to get a good immune response against that.
So do you like any of them that you've heard of? Any of the 60 plus? Have you heard of anything that you're like, that sounds promising?
I think the most promising one is the one from the UK. So the UK is a genetically engineered virus. Is a chimp adenovirus. So adenoviruses in humans are causing kind of like cold and pink eye. That virus.
Oh, I thought pook caused pink eye, but okay.
No, that's the pink eye, like the disease, like the virus.
Oh, okay.
Yeah.
Oh, okay.
Yeah. It's yeah.
So, wait, but poo's causing all this stuff anyway, probably. So,
yeah,
but go on.
I'm sure.
I'm sorry.
Yeah, it is. I mean, you have a lot of things in there.
Yeah,
but yeah, so.
But
so yeah, what about?
Weren't you saying that coronavirus is not in poo?
Well, it is in poo too.
Oh, it is.
So actually, this coronavirus, people are actually detecting it in poo. So people can go to the sewers, and then measure stuff, checking for the genetic material of the coronavirus in sewers, and people are actually finding it. So they can actually see overall how much. If you can just go to the sewers and measure how much is in there, you can get an overall impression of basically how many people are infected in the city, for example.
Whoa.
Yeah. So basically, Luke, you cut down on the Shiza action. We don't want you to get sick, so it's okay. Anyways, but tell me about the England.
So the vaccine is based on something called a vector. So people have actually had success with the same design with Ebola. So the Ebola vaccine that works fairly well, but has not really been thoroughly tested. That vaccine is based on the same technology that the people in the UK are using. So they're actually making this basically gutted virus. This is called adenovirus. It's from chimps, the chimp adenovirus, where you remove the genes that allow the virus to make copies of itself. But it can still go into cells just once. And that's when you make a virus that can only go into cells, but it cannot reproduce. That's what you call a vector. So they make a vector that makes the SARS-CoV-2 spike protein. So they make that, and then infect people with it, but it only goes into the cells once. It cannot reproduce. It just basically transfers the stuff in and makes a ton of the spike protein. And when it makes the spike protein, you just generate an immune response. So I think that's probably going to be a problem. I think that's most promising because there's a similar one that people tried with MERS, which is a related coronavirus that seemed to work somewhat. But also it worked for Ebola. So
that reminds me of this story that I heard about what they call Judas goats, because there's like an island, I think, where they would there's a goat problem on that island, and they would send a neutered goat, and because goats are social creatures, other goats would congregate around the Judas goat, and then a helicopter would show up with a guy with a rifle and just kill all the goats.
Yeah.
So
yeah. So this is basically taking the component of basically of a harmful virus, which is the SARS-CoV, the COVID-19 virus,
right,
and then putting into a sort of like a harmless virus,
right,
and then generating an immune system like that. So,
But weren't you doing something similar with was it the HIV? Weren't you doing something with an HIV virus?
It works the same way. So the way but I'm using it for a different purpose. I said you can use it for many things. So one of my vaccine designs is basically putting it into HIV, a gutted form of HIV, to make the spike protein. But all the ones that are vectors, there are different types of vectors. There's another vector called adeno-26. That is somebody in Boston, Johnson & Johnson, is working on that. That's also like the basis for the Ebola vaccine. This is very similar in design. But the other ones the ones in England use a chimp one, a different version. But they're kind of different versions of the same thing. It's basically like car models. Okay. They're kind of different, but they're also kind of the same.
Car models? You mean like pretty girls? No, you mean just cars.
Import models. I was not thinking of import models, but
well, because I know you're into that, but
different vehicles.
You're talking about cars. Okay.
Yeah.
But they're all transmitting the same, if not similar, RNA. Is it RNA that viruses?
Well, the thing that Moderna has that's RNA, but the one is like the virus actually contains DNA in this case. The one from the Oxford, in the UK, the Oxford vaccine, that's a DNA virus, and also the one from BARDA and Johnson from Boston, that one is also DNA. There's another one that is like
to the coronavirus, but similar enough to the coronavirus for the body to be able to develop the immunity that.
Well, it's just as a component that's identical to the coronavirus. It's sending a single component that's identical to the coronavirus, and that is what is supposed to cause the immune response.
Wow!
But that's the part that we know for that that is most immunogenic. So the immune response likes to home into this protein. So that's basically why people are picking it. It's also on the surface of the coronavirus. So if you have a coronavirus, like let's say you have a coronavirus particle, and if you cover it up with antibodies, then you inactivate it.
Right.
That's what we call a neutralizing antibody. A neutralizing antibody is basically if you had a virus and then you cover it with antibodies, then the virus can no longer work.
Right.
But that's if you have a neutralizing antibody. You can have, non-neutralizing antibodies. So you could have antibodies that cover the virus, but actually do not block it. So that actually many times makes it worse. So for example, this dengue fever. So the dengue fever vaccine was kind of dropped because the antibodies that you make against the dengue fever virus actually make it worse. So because what you cover with antibodies, then the stuff that's covered with antibodies, the covering of antibodies is called opsonizing. You actually have basically you completely cover with antibodies, and it goes into a different type of cell called macrophage, and then you get this so-called cytokine storm, which is basically the immune system hormones go crazy and cause a disease that's much more severe because this went into the wrong type of cell. It went into the wrong type of cell that has like much worse consequences.
Wow.
So that's when a vaccine goes wrong. So that's why it's like, you have to make sure that this doesn't cause it. And there's some history of other coronaviruses like SARS and MERS that you can form these so-called antibody-dependent enhancement, when you actually have antibodies and it actually makes things worse. So you have to be super careful about these things because all these things are issues and factors that you have to take into account and make sure that it works.
So do you think a vaccine, for example, a vaccine will be somehow approved faster? You've heard 18 months. That's what we've always heard in the news. Do you think something might happen in 6 months, let's say, or less? I know everyone's working on it, so I'm wondering if the rush to get it done is going to actually make, everyone's working on it, so I'm wondering if that's actually going to actually happen.
So, okay, the normal approval process is super long. It's like 10 years plus.
Oh, it's that long?
Yeah.
I'm sorry.
I
thought, okay.
So 18 months is already super sprint speed. It's really doubtful that it'll be that. Best case scenario. The thing that can accelerate, and also the thing is that you have to give it. So normally the way you prove that a vaccine works, you give it to some people, and then you don't give it to other people, or you give basically a placebo injection, and then it's basically I say, and then you're gonna see, okay, over time, did more of the people who get the vaccine get the disease, or did more of the people the placebo get get the disease? So if you can reduce in the vaccine group the number of people who get infected, then it says, aha, okay, it actually worked. That's the normal way you do it. Now, there's some people who have volunteered. I think it's about 3,000 people who have volunteered to do a challenge vaccine. So basically, like, you get the vaccine, and then afterwards they volunteer that somebody will, okay, inject me with the real virus, or give me the real virus. I'll inhale the real virus and see if the vaccine works. So a bunch of people are willing to take one for the team and get infected by the real thing with the real virus. But this is not, this is a kind of an ethical problem in a sense. But there's some people are volunteering, and then is basically that could accelerate things a lot, because the trial is what is the slowest.
Right.
So I see. So that means, I mean, they're obviously signing a waiver that they might die, right?
Yeah.
And then
That is
are they getting paid a lot? Do you know about that
I
part?
think these people are all volunteering, because getting
Wow.
paid for this kind of thing is also ethically questionable.
Oh, but they should just do it. This is important.
So people,
like, how about like like $250,000? That's pretty good, right? $250,000.
Yeah.
What do you think?
I mean,
A lot of money for
this is
help.
this is
You
not
need a lot of.
this is the regulatory people who actually have to take care of this, and
Oh, okay.
people like that. It's like I'm
That's
I'm
about
just
what I
telling
was.
you, like, what the technology and what we can make and stuff like that. And but yeah, there are people who are like volunteering to generate these challenge vaccines, and basically a challenge
Wow.
trial. So then it's like people would get the injections for the vaccine, and then afterwards they would just probably inhale the virus, and then see whether
Wow.
they get sick or not. Then you
Wow.
know almost immediately. You know.
So that's faster,
right?
So that's a faster trial then, right?
That'll be the fastest possible trial there is.
Yeah.
Yeah.
Wow.
But,
Another question. This one came from Dr. John Liu. But he was his question. I mean, some of the questions he would ask are ones that he knows the answer to, but I think he was more asking that, is it more reasonable to expect a full vaccine versus some kind of a treatment that would handle COVID-19 symptoms?
it's not like, I think it's like less than symptoms, but actually the virus.
Okay.
Well,
I think I'm pretty wording the question wrong, but basically he's wondering which should we expect to really happen?
There's a whole spectrum of things. So I think it's like you're gonna have both things. I think so. The treatments, there's several problems. There are problems with the treatment. There are problems with all. There are kinds of, the thing is really complicated. The way you treat the disease early on versus in the middle versus late, they're all different because you have different problems at different times. So let me just run through like a typical infection through you for a person who ends up in the ICU or dying. So typically a person will get, breathe in the virus or get it on their hands and then touch their face or something like that and get it into their airways. Infects, either something in their throat and nasal epithelium, basically inside your nose. It goes down to your lungs. And then many times it seems like you don't feel anything. By the time you feel something, you're already like spewing virus already for 3 days or so. By the time you feel something, and then you just get progressively worse for about a week. And then after you get bad a week, then you feel something in the lungs. And then it's basically you have a hard time breathing. And that's when you go to the hospital. But that means that, the entire time you already had the virus for about 10 days. So, okay. So once you go in there and into the hospital, typically it will take about a few days, like 3 to 5 days, until if you get worse, then you end up in the ICU, or less than a week or so. That's like median. It varies a lot, and then within 2 or 3 days of the ICU, you die or you don't die. And the people who don't die, they can be up to 40 plus days until they get out. So they
Wow,
can actually
that
stay there
long.
like for a very, very long time, in the ICU. So, but by the time they get into ICU, the funny thing is like many people already don't have much virus anymore. Your immune system already kicked it out. But it's basically the immune response that's actually making you super sick. So the immune response that is like the overactive immune response is so-called the thing that I told you about, like cytokine storm, where the hormones of the immune system are going through the roof. Those are causing all the problems and actually making you die.
Wow.
So when you have this kind of problem, I mean, this is not 100% like this, and then you may still have virus and stuff like that. But this is basically you have an immune problem late, and you have a virus problem early. So then it's basically like if you want to have a treatment, if you get rid of the virus early, then you don't have the immune problem late. So you actually have to have this like so. There was a early story that was featured on the New York Times that was all over Chinese social media of this nurse, or actually a doctor. I think it was a doctor or nurse. Anyway, she a healthcare worker who got sick. Then she started getting better. She felt okay, and then like she was like recovering, and suddenly after was recovered, then suddenly got worse again, and then died. And it's basically like what killed her in the end was the immune response, not the actual virus per se. The virus set up the immune response in a bad way, and then ultimately came. So then you have to deal with different things. So the late stuff in the ICU, people are finding that this thing called there are these antibodies and these drugs that countered your immune system. One thing called the target is the IL-6 or IL-6 receptor. Anyway, it doesn't matter what it is, but it's basically one of these immune hormones. And then basically like you make these antibodies that block your immune system. And by blocking the immune system, you actually make the patient better.
Oh, I
So
see.
that is actually what you have to do late. But early on, if you can get rid of the virus, then the second stuff doesn't happen. So how you manage a different stage of the disease is different. So you actually have to take all those things into account. So for example, one problem that we have is like remdesivir, right? We always say that remdesivir maybe this will help someone. But remdesivir is an IV drug. So you have to get it intravenously. So it gets into the vein. So basically you get a line. Basically you get to uh, basically you get a needle into your vein, and then you have your basically your saline, and inside your saline they inject the drug in the same line that they put the saline in. That's how you deliver the drug.
So that means you have to go to the doctor by that point.
You have to be in the hospital. You have to be
Yeah.
inpatient. So typically, as I told you before, by the time you become inpatient, it's about a week into your infection, from the time you notice them.
So it's too late.
So the window of opportunity for this drug to work well, the best time to use it was be early. But if you're going to put every single person who has symptoms in the hospital, you're going to overwhelm the hospitals. So it's a problem. So the ideal thing is that you have an antiviral that you can give early. So basically something that you can say, okay, you have symptoms, you test immediately and figure out that this person is actually, okay, actually positive. Okay, we immediately give drugs to the person. You just take it, stay isolated, not in the hospital, or maybe at home, or maybe, because you don't know at the beginning whether the person's going to have serious symptoms or not. You don't know that until people have shortness of breath, which is a week later. But the window of opportunity, the best time to use the drug is as soon as you feel it.
Wow.
So that's basically, the problem that we have. I mean, we have a drug that works like remdesivir. It's not approved in the US. And it's this Japanese drug, Avigan. And like China is producing it like crazy now. And Japan just sourced the materials. And they're planning to make 2 million courses by the fall. 2 million clinical courses. So basically, like, I think it's like 10 days of drugs for each person. So they want to make 2 million of those by the fall. So that's oral. You can just pop a pill, and that's it. So then there's like you could actually keep people like in a basically like in those hotels where they quarantine people with the mild symptoms, and then you could actually do it in that setting.
Wow.
So that would be the ideal. But remdesivir's problem is like you have to give it too late.
Right.
So that's one problem.
So why is that being so like? That's the only thing I've heard of on the news is remdesivir. That's all I've heard of.
Because it's an American drug. It's
Oh,
made by
okay.
Gilead in the Bay Area.
But then you're saying it's kind of not administered correctly, or we're not administering
okay,
correctly.
it's not no.
No,
I'm not saying it's not administered correctly. I'm saying it's like it's not so effective, and the time that you're forced to give it is kind of late.
right.
Like it's like you know from the flu, you know this drug Tamiflu, right?
Sure.
Tamiflu only works if you catch it early. If you give it early, it helps. If you give it late, it doesn't help. So then if you go to the doctor early and get the flu, you get the prescription early, it'll shorten your disease from 5 days to to 2 to 3 days. So it helps. I mean, all the antivirals that we know kind of work like that.
So that means maybe it sounds almost like you would suggest that this treatment is actually more realistic than an actual vaccine that just prevents you from getting anything.
Well, I think the vaccine is like, I mean, one is not. They're both good approaches. And
but it seems like a vaccine is. I've heard many people say it might not happen at all. There might not ever be a vaccine. But it sounds like there's treatments already happening.
No, treatments already happen and they're already working, and they're working now. It's like the thing is like the evidence there you'll see within the next couple months that people will show which ones work and which ones don't work. There are a whole bunch of candidates and people are trying that. And there's also like combinations. So you don't take just one drug, you combine a bunch of drugs. So actually HIV
a drug cocktail.
Awesome. A drug cocktail. Yeah, exactly. A drug cocktail. And that was actually invented by David Ho. David Ho in New York is the guy who came up with the HIV drug cocktail, the very first, I think around 1995. And this is basically what made from people had drugs before for HIV, but people were developing resistance and then eventually dying because the drug would no longer work. The virus mutated and then was able to bypass it. But if you give it a drug cocktail, it has to make too many mutations to adapt to it, and then it can never make it. So then it's like the drug keeps working forever. So for back in the day, HIV, people have HIV, you're okay with it with the drug for about 6 months to a year, and then it stops working and then you die. That's the end of the story. Nowadays, it's basically after the combination chemotherapy, the drug cocktails, the very first one, done by David Ho, which is basically took three existing drugs, combined them, and then people can, live out sort of a almost normal lifespan, with these. And there's like, if one drug stops not working so well, you just exchange it for another drug, and then you go for different combinations, and Magic Johnson is still alive. Right?
Yeah.
People expect that, oh, Magic Johnson's gonna die after he got diagnosed as HIV positive, and then
right,
but
he's still alive and kicking.
He's just fine, but anyway, so that's basically like what has happened. But now people are trying that. So the very first, about a few days ago, like I think last Friday, actually about less than a week ago, there was the results from a trial from Hong Kong University and several hospitals in Hong Kong, where they try 3 different drugs. One is a 2-drug combination of things against HIV, and then called Kaletra. And then that's like actually 2 drugs. And then there's also, they took another drug that was a very old antiviral that people have been using for herpes and other things like that. And then they took also interferon 1 beta, which is a general antiviral. That's a biologic, means that it's not like a small chemical molecule, but it's actually basically basically the immune system hormone. And they combine those three and give people all three of them at once and was able. But the most remarkable thing is basically this Kaletra was actually by itself doesn't work. So people actually had published maybe like a month ago that they had a clinical trial of just that one pair of drugs, and giving that one pair of drugs doesn't work. But if you combine it with a whole bunch of other ones, suddenly it works.
Wow.
So that's the thing. So basically, this is the first time that people use the combination, and combination is like super powerful because, for example, hepatitis C was a big problem, and then the best drug that we had would cure people by 50%, and now it's like, I think it's like now with a drug combination that actually came from Gilead, the same company that makes remdesivir. That drug combination that is basically cures people. And one of the problems of their business model is that, okay, if we're going to cure everybody, nobody transmits to anybody. Now we're going to cure ourselves out of business because then there are going to be no customers. So, but anyway, so that's what they were planning on. They're planning that we're going to have huge, maybe like we're going to have a huge business. We're going to cure all these people. And then after a couple of years, it's going to be a trickle. But we'll have made all the money in between.
Wow.
That's why they're charging, I think, like 50, 60K for the entire treatment.
Wow.
Jeez.
Yeah.
Well, that's a lot. So, I mean, is it the way you're explaining it? It almost sounds wise that I to be hopeful that the treatment will be successful sooner. Is that possible?
I think that's definitely the case. It's like, I mean, there was another paper that came out from people up the street. They actually showed 30 different drugs that actually work in cell culture. If you put it in a dish, and the 30 drugs, and the drugs that I mentioned to you before, they all worked in cell culture before. They might not work in the person, but they already work on a dish. So if now it's basically, okay, and these are all clinically approved drugs. So now it's basically, are we going to find combinations? Are we going to find we're going to test these on people, and that's what they're working on now, to see if the drugs that are already clinically approved, things that are used for other purposes, and that's basically that's called drug repurposing. You just take the drugs that are already used for other purposes, and then you use it for this. And that's a easier approval step because you don't have to figure out if it's toxic to people or something like that, because you're already given to people for a long time, and then or you've already done all the testing in the clinical trials. First, you test for toxicity, you test for dose, and then you test for effectiveness. Those are the three phases of clinical trials. Phase 1 is basically toxicity. The phase 2 is like dose escalation until you know the right dose to use. How high can you tolerate this? And then the third one is basically you try to see if it works. So those are the typical phases, but that has already, at least 1 and 2 has already been done for those drugs. So now you have all these slew of drugs that you just have to try on people and see if it helps. So yeah. So anyway, let me get back to the vaccine.
Yeah.
So the vaccine. So the vaccine, from what we know, is tough because when a virus spreads through your body, throughout your body, then it's basically you could basically get, it's called a systemic infection. Basically all over your body gets infected. Or there are certain viruses that go to mucosal targets. So mucosal targets basically like where the surfaces in your body that have mucus, like your lungs, your intestines, those kind of things. It turns out those type of viruses that infect your mucosal surfaces, you don't get immunity to it very much. So in like all the coronaviruses that we know of, you don't get immunity more than a year, typically. The typical coronavirus immunity. So if you get a vaccine, probably you will have to be like a flu vaccine. So you have to get re-injected with a vaccine every year. I guess it would have to be like that.
Wow.
So that's sort of like the best expectation that you should have, realistic expectation that you have, that you actually have to have like a yearly shot
So is that a booster? Is that considered a booster shot then? Since
it's kind of a booster. Yeah, a booster is just to make it stronger, but this one is just because your immunological memory drops.
Right.
So if it drops over time, and people actually check like the other coronaviruses that don't cause disease. So there are two other beta coronaviruses. So SARS-CoV-2, the COVID-19 virus, is a beta coronavirus. So its closest cousins that don't cause severe disease is that's called HKU1 and L63. There are two other coronaviruses that are infecting people. And people just go back and check, and those actually have about 45 weeks immunity. So less than 1 year. So you remember your year is 52 weeks.
Right.
So it seems that the immunity that you get to those viruses is about 45 weeks.
Wow.
So.
And why is that? Why is it that like mucosal viruses?
So it seems like the natural memory cells. So they're memory cells that like the memory cells in the mucosal surfaces, like in the lung or in the gut, they will actually go out of it. After a while, these tissues turn over a lot.
I see.
And what happens is that basically they turn over a lot. The memory actually moves out and goes into the bone marrow. And when it goes into the bone marrow, it forgets. That's what people seem to think, that this is basically what's going on.
Those dumb bones.
That's stupid marrow.
Yeah. But this is the way it works. So it's like, so I don't know why people actually have this expectation that you're going to have this vaccine that you inject it once and then you're going to be immune for life. There is no basis to expect that.
Yeah.
But this is going to be probably a recurring vaccine that people have to keep vaccinating.
Wow.
But you have to also be careful with this kind of thing, because many vaccines, as you repeatedly give, you're also more likely to get side effects from repeated vaccination. That's also possible. I mean, it doesn't always happen. With the flu vaccine, that doesn't happen, for example. But there are certain vaccines, for example, back in the day when people vaccinated against this disease called smallpox, and there was this smallpox vaccine. If you repeated it many times, your chances of getting like a side effect increased with each repeat. So.
Wow. And why would they continually? Why were they like repeatedly?
Yeah. Most of the time, the people did, that disease was actually exterminated by vaccination. 1978 is when the virus disappears from the face of the earth, except in 2 labs.
Right.
But most of the people who were working on that virus had to get revaccinated. And then also because the immunity kind of waned over time, so people get a booster shot, like what Eric was saying. Right. You get a booster in order to strengthen your immunity again against that.
So I had a question that maybe kind of sort of relates, but by Jian Shen, he's our friend. He's a toy guy, right? Anyway, so yeah, he basically asks, he says that it's common knowledge that vaccines take years to produce and discover, so we're aiming for luck right there. But he says, besides luck, what other bottlenecks are there in the vaccine world that we should know about?
Well, that's what we talked about earlier. Like when you do a clinical trial, you have a group of people and you have to wait until they naturally get infected.
Right.
So, but this is like a really big issue. For example, in China, they had a drug trial for remdesivir, and remdesivir came out to not work. Well, because you need statistics. And then we have something called statistical significance, which is basically the effect is strong enough that you're 95% confident that it worked. But if it doesn't reach that level of 95% confidence, you consider it to be failed. But
oh, wow.
What happened is, like, how can you be sure that the statistics are working? So the statistic, how confident can you be? Let's say you have like a very big difference between two samples, like the guys that take the drug from another. If basically everybody who takes the drug is alive, everybody who didn't take the drug is dead, then you have 10 out of 10 perfect. You don't need so many people. 10 is enough probably for you to be confident, 95% confident. But if the effect is small and variable, then you need hundreds of people.
Oh, you mean so like they have Chinese prisons You know that's you know it. You you
No,
know there's you know that there's poor minority prisoners that are just getting screwed right now.
like Uyghurs.
Yeah, I didn't want to say
Yeah.
that, but yeah,
Yeah.
yeah,
So I don't think
they
they
are
well, as far as
testing
I,
subjects.
as far as the stuff that was published, they didn't do any of that.
Well, how about North Korea? They can go ahead and just
Well,
you know
what
use
happened
some
is
of
like
those
they
use
had
some of those guys. Huh?
so what happened in the Chinese trial, they were aiming for 400 patients for each group, the treated versus the non-treated, and they ran out of they didn't get any more patients. They were I think like 280-ish or 240-ish. They didn't get any more patients. So they ended the trial early because they couldn't get any more patients because they ran out of patients.
Oh wow!
Mm.
So basically,
So
with
they have a
240
heart.
patients, they couldn't tell whether the drug was working or not. But then
Wow.
the NIH had one here in the US combined with people in Europe and in other places where remdesivir, and they had 1,000 patients.
Mm.
And with 1,000 patients, they could reach that 95% confidence that it actually did something. So, but I mean, it did something, but it's not super strong. It just makes it a little bit better, not like for the reasons that I told you, like probably just taking it too late for it to work well.
Mm-hmm.
Mm.
So that's sort of the problem.
So I don't know if it's jumping topics too far, but Dr. John Liu also asks can you explain the effect of vitamin D? Because that's all of a sudden a little more in the news recently, I guess. I've been hearing about it. What does that have to do with anything?
Well, vitamin D in general, it's if you have a deficiency for vitamin D, then your immune system is depressed. So a lot of people are like, and a lot of people, myself included, uh, are low for vitamin D. I was like,
That's because you work in a lab. How about you, Luke? Are you low in vitamin
Oh,
D?
I'm probably. Well, my last blood test said I was fine, but like I'm probably low, especially nowadays. Since I
yeah,
Right.
I was like so low. I was like tenfold below the lowest acceptable level at a certain
Wow.
point.
Time to
So
go get some
I had to
sun.
supplement. So I was not getting out there. I was not surfing that much anymore. So that's you have to
Mm.
get out in the sun. So
I hate that.
Yeah.
yeah, it's
Is
like
is that completely
it's like non-otaku kind of thing.
is there any science to vitamin is there any science to vitamin D, or is that equivalent to drinking
No,
bleach or whatnot?
no. I think vitamin D is like that. Yeah, you definitely don't want to be vitamin D deficient because your immune system actually does. Vitamin D is you know is a hormone. Vitamin D binds the vitamin D receptor. The vitamin D receptor is a what we call a transcription factor. It turns on a whole bunch of genes. And one of the things that it actually does, besides, um, is modulate your immune system. But it also modulates like bone density and things like that. That typically but is definitely important. You know, so I think it's like to have a healthy dose of vitamin D and to be in the right range is good. But vitamin A and D also has a different problem that if you take too much of it, there's also toxicity. So you can actually, it's best known for vitamin A. Vitamin A and D many times go together. They both work in similar ways. But for example, when people say that eating polar bear liver is toxic, people can die from eating polar bear liver.
I had no idea.
Yeah. So be
Is it
careful.
because it's chock full of vitamin A and D?
Yeah. With vitamin A. So you get vitamin A toxicity. So Inuits knew not to never eat the polar bear liver.
Just
Wow.
the tiny bits of it.
Any tiny bit of it is okay. Yeah. So if you want to have like polar bear liver pate, go for
Just
it.
one cracker.
In really, really small doses. I don't know exactly how small of a dose is safe, but I'm pretty sure it's like it's gonna be low.
So I saw an article on Now This News. Now This is kind of like they do a lot of like news articles about politics and health and stuff like that. And they mentioned something that I thought was peculiar, and that was nicotine. And apparently like nicotine, the percentage of like people who are like being infected, are like that use nicotine is apparently like low.
Yeah, I don't know exactly. The problem is like with all these kind of things is like this. You have like, let's say you have like what you call like the covariates, like a confounding factor. If things that go together but are not necessarily related. So initially when people said, okay, uh, men in China, when people had in Wuhan, they said, oh, men seem to be dying a lot more than women. And then it says, but then it's like, then figure out like, oh, it turns out that men smoke a lot more and their lungs are in much worse shape. So
Right.
therefore you actually had, I mean, it had nothing to do with being men. It had more to do with being smoking and with smoking. So all those things are correlated. So you have to tease all those things out. And it's like, that's why you have that's why you have professional epidemiologists who actually go and tease these things out to make sure it's not a covariate or it's not some other factor that's sort of associated with a behavior, associated with the place you live, and so on and so forth, to figure out what is actually going on. So the nicotine thing,
But
like, I'm on the fence. I don't know yet
right.
whether there's like.
Have you heard of that? Have you heard of that one?
Yeah, I heard of that early on, but the thing is like, if you find sort of an association, for you to believe it, you also have to have a plausible way of how this would actually be working. So how do you distinguish between something that's believable from something that's not so believable?
Well, not all nicotine users are using it, are inhaling it. Like, there's
on the
patches.
patch or something like that. Yeah. So I don't know exactly whether that is a factor or not.
Right.
So I looked into it early on, but I didn't see something that was like super convincing. I mean, it's an observation. So people have seen this thing, but whether this nicotine is the factor or something else, it's like, it's really
Well,
difficult.
I mean,
Like, for example, you could think of it like, okay, you could think of it this way. So I'm just making this up right now. But for example, you say like, okay, if people, that people, when people stop smoking, they tend to gain weight.
Right.
And people say that people who are obese do worse, with COVID-19. So maybe it's just that they're not getting fat. So basically, you're keeping if you were to keep the people thin, then they're not gonna die.
Right.
And smoking might be a way to stay thin. I'm just making this up right now.
How people like not gain weight, so much weight. So
yeah, exactly. So you stay healthier that way.
Right. Like let's give fat people meth. It'll save them from COVID-19.
Yeah,
like that kind of logic.
Exactly. Yeah, kind of like that. It's a little bit. So I don't know exactly if this is the case, but this is the kind of things that you need to consider. This is the kind of thing that you need to consider. So
yeah, I thought when I saw that, I thought it was like kind of weird, and I wanted to ask you about it just because I thought it was so weird.
Well, it's like, I don't think it's weird. It's like, I mean, these things are, if they're observed and they're reliable, you should take them. Like, and then you should, basically what you have to do is like, you have to take that initial observation and then hunt it down, and then you can find a chain of causality. Okay, so the nicotine is doing this and this, like, you have to somehow link it to the problem that you have in COVID-19 to make it believable, so you can convince yourself that that this is something real. So that's
how do you feel about the way California has been slowly kind of trying to open up again?
Well, so I think
that's a big question. I love it.
I think it's like, you have to look at it carefully. In general, if your number of cases are increasing, it's like playing Russian roulette while you're still adding bullets. So it's not a good idea. Like, if you need to play Russian roulette, the best policy would be that you start playing Russian roulette when you are removing bullets.
Right.
So every time that you shoot is less likely than the previous time that you shot that you're gonna end up dying.
Right.
right? So that's the kind of thing. Uh, the thing is like with California, I don't know with which area the from the things that I saw is like we were kind of um, the case number is sort of steady,
Mm,
is not really going down.
mm,
So that's kind of a little bit risky. I understand that you actually have to balance the things, but it's like also depending on where people were, social distancing better or worse, and
mm,
that's the problem. So the reason you have to do this is because okay, how we're gonna play this game, how we're gonna manage things in this world. You have to get the numbers down sufficiently so you can do contact tracing. So contact tracing means that you're gonna go, if somebody is sick, you're gonna find everybody who's contacted, test every single person that's contacted, not even directly contacted, but also the people who went to the place. Because if somebody, let's say, is sick, touch their face,
mm,
got some saliva or snot, put it on the door. You have to trace everybody who touched that door also,
mm.
not just the person who was talking to him or something like that. But you have to also see like for the last 3 days since this person touched this door, who else touched that door?
So if it's a restaurant that's actually open or something, there can be hundreds of people.
So yeah, so
Right.
you need to
Yeah.
contact trace all those things. So you can
Impossible.
see
Right.
the problem. This has to be done on a daily basis. So if you actually have a, let's say, 100 people, you have to have basically you have to have a group of people who contact trace and follow up that case and find out all the people for several days, maybe a week or maybe 2 weeks, until they can figure everything out and get everybody of those people quarantined. But
Mm.
if you had like thousands of them, how many workers will you need to do this contact tracing? So if you had like 100 cases a day, it doesn't mean that you're going to have 100 people contact tracing, because the next day you're also going to get 100 cases.
Mm.
And then so it is impossible for one person to do the contact tracing in one day
Mhm.
to figure out everybody who's been in contact with this one case.
Mm.
So you need many times over the number of people doing contact tracing and following up that case and quarantining and testing, than the number of cases that you have. So there's a capacity issue. So you want to get down the numbers sufficiently that you can actually do this realistically. So
So the numbers are still too high in your opinion?
yeah, I think the numbers are too high. But it's like the thing is that the numbers are too high is because people are not socially distancing properly.
Right. Well, I mean, you have like the protesters. I just posted on my Facebook
Yeah, the Huntington
uh,
Beach thing, that's
yeah,
crazy.
yeah. There was a collection of 250 like photos and some of the most insane images I've seen of like what's going on out there.
Yeah,
Um,
I saw that.
I had a conversation with a business owner, a friend of mine, and he's got some pretty unpopular like attitudes towards I mean, he's not unsensitive. My friend's not unsensitive to like what's going on, but like, he is definitely in the like we need to like look, the deaths and infection rate for Southern California specifically is not nearly as bad as it
New
was
York, right?
New
Yeah.
York, or is it was even ever guesstimated for this area. And we need to, albeit safely, like get things, picking up again, because
I think
people are, this the entire the economics of everything is like really messing things up.
yeah. I mean, I completely agree that it's like that is
Mhm.
completely messing things up. And there's like the question is like how do you do it in a way? So basically, like let's say you reopen in a bad way,
Mhm.
you could end up with the problem of the meat industry, right?
Right.
So now it's like we have a shortage of meat. You can go to Rouse and you can only buy 1 or 2 packages of meat because there's a shortage.
Right.
But just imagine if you have a supply chain shortage of everything else.
Right.
And it's basically how many things are critically dependent on a steady, reliable supply chain. If you have a place where everybody gets sick altogether, Then it's like, or if they, if you get these people sick, and in addition you get your healthcare workers sick because you have your N95. N95 means that your mask will take out 95%. 5% is still possibly getting through, and then you're gonna have much more of it at the hospital. Now your healthcare workers, even with the PPE, are gonna get sick. I mean, you can see how this thing, as a chain of collapse, it can really do a number on you. Basically, let's say if you get all your truck drivers sick, or you get a particular industry sick, it's I mean, I'm all for getting the things, but this is like even the people who are successful, like you see what happened in South Korea just now. South Korea tried to reopen up, and then they had this case, like they had, I think, like 40
Nightclub?
cases. Yeah,
Was it nightclub?
Yeah,
Was this
nightclub.
now?
Yeah, that's basically that got 40 some people, infected now. And now you have to deal. Okay, so he said, okay, the nightclub thing is not so safe. So
Duh. But yeah, okay. Duh.
So you have to manage that. You really have to go down to zero for it to be, to work. So right now it's like basically you want, even if you don't get to zero, how can you manage with not going to zero? So if you don't go to zero, you want your natural infection rate to go down.
Right.
So the natural infection rate, if it goes down enough, eventually this will disappear. But it's super hard to do with this virus,
Right.
because you cannot just look at people. Like with SARS, you can say, oh, if he doesn't have a temperature, we know that he's not infectious.
Right.
But we don't have that advantage at this point.
So I guess we had one listener who Jun Watanabe asked, what are the chances then, do you think, are the numbers going to spike up and put us back into a bad situation? Do you think that's going to happen?
I think it's probably going to be some spike of some sort at a certain moment, but that is my guess, because I can see that basically we're not developing any, basically I'm not seeing anywhere that we're developing basically what people call herd immunity. And I told you before, the virus, your immunological memory only lasts about a year, right? So even if even we got everybody immune at once, then after a year it'll be going away.
Right.
So then it's like that. And we actually have things like this. So for example, epidemics like measles always like comes in spikes. And what are those spikes? So first is like basically what was happening before is like all the kids got infected or vaccinated. And then new kids are born. And new kids are born that were either not vaccinated and has never seen the disease before. And then once you get enough kids in the school that were not vaccinated, then you see a spike of cases. And then everybody becomes immune. And then you see the disease to peter down, and then don't see it for a while until you accumulate the kids again. So you have to have the susceptible population up to a certain size to that. The problem is like with this thing, everybody's susceptible. So everybody's susceptible. And because the virus only lasts for a year, even if you infect people over time, by the time that these recent people became immune, let's say from the real infection, they're going to be the guys who got it a year ago, they're going to be susceptible again.
Right.
Wow.
So I think it's like, in that sense, it's like super difficult. That's why
But this is in theory, right? Like, I mean, like, because, just because a majority of mucosal viruses do not.
I wouldn't say the majority, all.
Is it an all thing? Like absolutely 100%. Like no, like no ifs, ands, or buts.
They don't have long lasting immunity. It could be like, I think the longest one is like 2 years or so.
Okay. So
I don't think there is a single case that I know of a mucosal virus that you can get permanent immunity.
We're fucked.
So I had another person ask named Jane Hirata, who's in Hawaii, and basically asked something kind of similar, but I guess they have a concern that although they think maybe they're kind of handling it pretty well. I would say it's late, but it seems like they have less cases coming.
It's like
that
the Hawaii,
like for some reason, right?
For Hawaii, it looks really good.
Yeah, it's low, right? Like I think there was 3 new cases yesterday or something like that. I heard like 3. But I guess their concern is what about, because they're opening stuff up, that tourists are going to come and create a bigger problem. So she asks, what can locals do? Just wear masks, or what is the?
Well, it's like, I think it's like, yeah. And the most important thing is to enforce the guys from outside to wear the mask.
Oh,
The guys coming in should wear the mask for sure.
Mm-hmm.
I don't know whether I show you that graph, like how the mask thing works, like how you decrease the probability of getting infected. If the person who is sick or has the mask reduces much more than if you wear the mask. It's not the protection is not.
So both is better.
Both
ultimately.
is always better.
Yeah, of course, right? Yeah.
Yeah, I heard somebody like putting the analogy is like, okay, if somebody were to pee at you and they're wearing pants, and you're wearing pants, it's gonna be okay. It's like if the other person pees and you're wearing pants, you're still gonna get wet. You might get better, but it's like
that's great.
Awesome.
That is great.
Awesome. So, what's your opinion on how Sweden has handled the coronavirus? Because they're using.
So Sweden is trying to get herd immunity.
It's like an experiment, right? But yeah. It's weird when I hear the word experiment, because that's just what they decide to do. It's not really an experiment. But I guess the rest of the world is looking at that as an experiment. Is that correct?
Yeah, I think it's basically. It's
weird.
Well, I don't know exactly what went into the calculation, but I think it's like ultimately, I think it may not work because of this immunity issue that I told you, that
right.
the memory, like the immunological memory is limited. If the immunological memory is limited, is basically you're going to get people sick and people recover, but people who recover after a while are still going to be susceptible again. So that is the thing. That also actually impacts your flattening of the curve. So you have to remember how big your epidemic can be depends on the size of your susceptible population. So the bigger your susceptible population, the bigger your spike can be. The bigger your the bigger your epidemic can be. But if you keep people being infected at a very, very low rate, the immunity that you build up in the population as a whole is only a small fraction, because by the time that you reach a year, all the people in the back already forgot it. So you just keep keeping a really large susceptible population.
So why is Sweden continuing that?
Well, it's because I don't know.
If they knew, maybe they don't know about this 1 year memory thing with
I don't know exactly what they're
mucosal.
Okay. But it's like
it's like if that what you just explained alone kind of tells me they shouldn't do it.
Yeah.
Like in one sentence, I think I'd be convinced. No, I mean, it's like we shouldn't do that.
Take your classic textbook. Okay, it doesn't show up here now.
Wait, it did for a second.
Yeah, virology.
Oh yeah.
Fields virology. This is the textbook for virology, and this is basically and in there, they have this.
Page 1.
No, it's not page 1, but
okay.
It's page 200 something in the viral immunity, and they list how long each virus.
Luke, you got to get out and get that book, man.
It's expensive. It's a $500 book.
$500?
Yeah.
Oh my God, that's a ripoff.
So anyway,
I'm gonna find that shit on. I'm gonna buy that shit on eBay.
Oops, I disappeared. Anyway,
where's the illustrations?
Yeah,
Luke. There's a table. Okay, let me see. I'm gonna quickly share this with you.
You don't have to. I don't know if I'll understand it, but go for it.
No. It's a table. Just a super. Hold on. Let me see if I can pull.
All right, somebody online just said the pee analogy is really bad.
What are you talking about? It is really good.
No, I think bad meaning good, or bad meaning just gross.
No, it's good.
Yeah, it is.
Yeah, like that. That's
it's good. It's just so gross. It's like, oh.
Okay, let me see if I can share this picture right now with you. I just took the picture from my.
Also, I guess, are you a multitasker? What do you think about cameras? You know, like the heat sensing cameras. Someone
I don't
mentioned
think that's going to be so useful because there seems to be a fair number of people don't even get
temperatures,
the temperatures.
right? Yeah, and there's going to be a bunch that are asymptomatic. But I was just wondering, what's the point of that? That doesn't make any sense either. Like they just,
I don't
if
know.
you're just showing symptoms,
like it might give you a false sense of security.
maybe that helps in 25% of the cases, but the 75% still might be.
False sense of security is good enough.
Is it?
Yeah.
But that means like, you know, the restaurant, they're like testing temperatures and stuff like that. It's like, that's not going to work.
No, of course. I mean,
what's the point?
Like, a long time ago that didn't work,
right?
But like,
so the time that you actually shedding the most virus seems to be just when you start getting symptoms. And after you start getting symptoms, the virus starts going down.
So you're spitting fire before you don't. That's not even. It's too late.
Well, like that means like you're feeling a little achy. You don't feel particularly good.
But that means if you have a temperature, if that means if you have a temperature, you're better off. You're already expelled viruses, right?
You see this?
Yes.
Yeah.
Yes.
Okay. That tells you which virus and how long your immunity lasts. So you go the mucosal infections there.
Mm-hmm.
You know.
Yeah, influenza, RSV,
but everything is short in terms of months. Everything else, all the other ones are like in terms of years.
Wow.
So you say like vaccinia is 75 years. That's the pox virus one, the smallpox. That's how long you have like immunity.
Wow.
We're typically good at making vaccines against things that you're naturally immune to. Right. We're not very good at making things, vaccines against things that are short. And the influenza is even trickier because you have that 30 months, but the problem is like you get a different strain. The strains mutate, so that 30 months is not really useful. Because in less than 30 months, you're going to have the next strain. Like that's why you have the yearly vaccination from influenza. But it's I mean, and this is the textbook of virology. So I don't know how people got this idea that we're going to get a vaccine that's going to be permanent, for your lifetime.
Is that just the news?
I think it might be just the news.
Yeah. Oh, do you know what I was really proud of? And it's not related to that chart, but I was really proud of the fact that maybe 2 weeks ago or so, it came onto the news that they're saying the virus might have been created in a lab escaped from a lab, or it was created by man, human created. And then I was like, oh, we talked about this a month before that.
Yeah.
And said, oh, you said it basically looks like it's definitely not man-made or human-made.
It doesn't look like it's man-made. Even like the directorate of national intelligence said like we don't see anything here that looks like it's man-made. But then you're getting into this politics and entire business now.
Yeah, but it's one of those things where that came out really late. Like, wasn't that something discussable a month earlier? This just came out like 2 weeks ago, and I was like, "What is this now?"
But
that's crazy.
At least the New York Times. The New York Times had an article that said that
we question this shit. We're smarter than they are, huh, Luke? We question that shit.
We were on top of. We were asking.
Yeah, I was so proud of myself, and I was like, Gerald already smashed this thing to bits, and only now is it getting to the news. It's crazy.
This is
pathetic.
There was a Medium article.
Medium? That's just a blog site. That's a blog spot.
Yeah.
All right, it's a blog spot on steroids, but okay.
But people are going off on these Medium articles. I don't know. It's
yep.
It's catching up, especially with a certain type of population, and then you have this Dunning-Kruger effect that everybody now is an expert in everything, and then it's like the thing is like a lot of these things are really, really complicated, and they're very, very nuanced, and there's like little small details make a huge difference.
Like taking, like drinking bleach.
One thing that's important, and it's like you find something that is like there's a correlation or something like that, but you fail to look at the other things, and then that can lead you astray very easily, that you fail to look at the other things. You see the stuff in front of you, your attention is to this thing, and then he says, oh, I can see the relationship. But then it's like it says but the people who are trained professionally are trained to think about all the other things that you're not looking at, right? So that's basically the thing. Like sometimes the stuff that's in front of you is the important thing, but you're trained to look at the stuff that is not in front of you, and that's a lot of it that allows you to. It's like frequently you have like a mechanic trying to deal with a particular problem in your car, and the place that you actually see in the car, that where you see the problem is not exactly the origin of the problem, and you have to track down the chain of events to actually find where the problem was.
Those are the good mechanics. There's not a lot of those.
There's not a lot of those, yeah.
No.
Yeah, but
unfortunately,
that's also like for example, in medicine, we actually taught kind of thing. Like one thing that's that we're taught, for example, anything that inside your abdomen, you cannot trust your feeling where the pain came from, because that's why why does the doctor have to tell you like, oh, if your appendicitis, they have to palpate, and there's like you have to push it, and you have to push it. If you push the right part, it actually feels a lot worse. But frequently people feel it in a completely different part of your body. So for example, one thing is, for example, like your diaphragm. If you have a perforated diaphragm, the typical feeling of the perforated diaphragm is pain on your shoulder. So this is how people feel it. It doesn't mean it's there, but it's basically your body is not made to, but it completely feels like it's on your shoulder.
Right.
So this is the kind of thing that you have to know. And this basically, not the obvious things are not always the right things.
There's a question that I was just thinking of. There's this latest thing about like children, getting this weird
Kawasaki disease like thing.
Right. Yeah, Kawasaki disease.
I don't know what is Kawasaki disease.
It's basically inflammation of your blood vessels.
Oh wow.
And like, does this have anything to do with like the current strain of the coronavirus that we're experiencing, or do you think it maybe has mutated again in the United States? Or
no, we actually see there was an early mutant in the there is one thing that came out, I think, in a whole bunch of, there's a bioarchive paper. It's basically, this is not peer review yet, but actually it looks pretty good, which shows that there is some mutation there's a mutation in the virus, in the spike protein, that seems to make the virus more transmissible. And the way they tell whether the virus is more transmissible is that over time they seem to see this one more than the original one. So it seems to, whenever that you see a place, it seems to win out. But I'm gonna share this thing with you guys.
You posted something.
Yeah, I posted something, but it's not completely clear that this is. I mean, that's a reasonable hypothesis, I would say. It's something that definitely seems to be, that's reasonable, and the data seems to support that. But the patients that get this strain don't seem to be doing worse. So, for example, if you look here, I'm gonna share.
It doesn't have it's not as virulent, but
it's not more virulent, but it seems to be more transmissible. So, okay, let me show you.
That's a bummer. I mean, I guess, yay, it's less virulent. Oh, it's more transmissible. Right. You get one or the other.
It's more transmissible. That's bad too. That's more.
Yeah, it's horrible.
Guys, can you see this?
Yeah. It looks very complicated.
So if you look at the graph, the blue one,
it looks like Tetris.
So yeah, so your x-axis, like the bottom.
Our sound went haywire here.
Yeah, it sounds like
I have a train And I live next to the Miramar Naval Air Station, so that's
Oh,
Wow.
okay.
that's
Oh.
these are the F-18 Super Hornets flying over.
Oh wow.
So yeah, if you actually look at this thing,
Yeah.
blue versus the orange, you
Right.
see that over time, the proportion of blue seems to be increasing. The drop in the end, because this is from genome sequence, but it takes some time to sequence the genomes. So the more recent ones you don't see as much because people haven't gone around to sequence the stuff. It takes about a couple of weeks for people to process this to do the sequencing. But the
Right.
proportion of blue to red, that's what you should focus on, is
Right.
basically increasing blue. So whenever blue appears, eventually it seems to take over. It seems to be more prevalent.
Wait, and that's the
So,
mutated. That's a mutated.
Yeah, so it's basically there's a amino acid at position 614 of the spike protein that's originally aspartate, and then it became glycine. It makes the protein probably more flexible. But let me show you another thing. So yeah, so this is a movie of the D versus the G. So originally in China, you see there was all D, 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 D.
The D
And then
virus.
suddenly the yellow appears. And then this yellow one just
Wow.
goes and then spread to Europe.
Oh.
You see, but over
It
time,
to Italy and stuff.
it basically like whenever like in the US had a little bit of the yellow, but it seems to have gotten this yellow one from this and then imported the yellow back to Europe. And then it's like, and then you see this explosion that over time, the yellow becomes more and more. And that is
Yes.
basically, that's the G version. That's what we can tell from the genomes.
So
But
there was a little bit of news that saying that basically that all the virus in America came from Europe. That was like 2 weeks ago also, right?
yeah,
it started
vast
becoming headline news.
well, that's not true because, for example, the one in Washington definitely came from China.
I see.
Hmm.
Yeah, just weird that headlines and what speaking
it
topics.
it mostly came from Europe.
Yeah.
We can be pretty confident that. So these
Wow.
are the ratios in the different countries of the D versus G. And you see, China had very little of the G. Initially, it came from China and then went, but now it's like the things over time. So, okay, so you can actually have more. You can have more of the G because, initially it came in and there was a race and the G won. But you could also have more because now, let's say you actually had a whole bunch of G in the United States and then re-imported back to Europe. So you have multiple introductions. So if you have multiple introductions, you can also skew the ratio that way. So that's what's not completely clear. The data seems to support that this virus is better at spreading, but we're not completely sure because you cannot exclude the fact that it's because now you have lots of importations from the United States which had this one. So anyway, so that's.
So what do you think lately there's been more in the news anyway, there's been more blame on China all of a sudden. Like it kind of like dissipated because there's a big problem, but now it's like back to China hiding data and hiding what do you think is the truth there? It's like hiding data, hiding how many people died, hiding the virus all of a sudden. But I'm like, they didn't hide it, did they? Or did they?
Well, if you actually look at what actually was reported in January, I don't think there was very much hidden at that point. I think it's like after March, is like after they got maybe pissed off or wary of whatever we're doing, they started not telling anything. I mean, I think that the stopping of sharing of information looks more like a consequence of us accusing them than.
Oh, you mean I wish they would have told us? You mean that? When Trump started saying that, right? I wish they would have told us. And it's like, didn't they tell? I thought they did tell everybody.
This is when it gets mixed into the entire politics business.
Sure.
Like, I mean,
that's what.
According to the New York Times, the strategy for winning the November election is to blame it on China.
I see.
Of course.
Wah, 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 wah.
This is a dangerous game to play.
Yeah. Well, China gets its butt hurt pretty easily, and obviously Trump gets his butt hurt just as easily.
Yeah.
So you have two like countries that get their butts hurt really easily and like will storm off to their rooms and slam their doors, and no one benefits.
Yeah, and the problem is the biggest problem here is that if the world as a whole doesn't work together to solve this problem, we're not going to definitively solve it ever. And the reason being is, for example, let's say we don't help the countries in Africa who have a poor healthcare system. If we don't manage to shut it down in Africa or South America or wherever else, we can eventually, even we clean out completely the United States, we're still going to get it re-imported in some way from those places. The reason we had, the reason we manage Ebola in Africa is because we wanted to have Ebola managed in Africa so we wouldn't have to manage it here, right? So, going around the world and doing public health kind of things is to avoid us having to deal with it locally. Right. It's not, we're not being good Samaritans in a pure sense.
Right.
Yeah, of course not.
We're actually helping ourselves by having it managed in somebody else's turf, right? Right. If it's not a problem anywhere in the world, it's not going to be a problem for us. If China didn't let us, if China didn't let us have basically a CDC monitoring station for flu, where we can monitor the strains of flu every year, we would have no flu vaccine. Right. Because the way we're detecting flu vaccine is we're checking the strains that come out in ducks and chickens and birds and pigs in China, and then predicting which is the strain that's going to happen next year. They don't benefit from the flu vaccine. We in the Western world benefit, because what happened in China the year before is what's going to be in Europe and the United States the next year. So
I'm smiling because I learned it from the last podcast with you. I didn't know this.
That was the biggest mind boom for me.
Yeah, I didn't know that. I was like, it is?
Well,
so anyway,
here's actually, but that inspired that made me want to ask a question, and that is that, like, okay, since the influenza virus is basically like figured out in China, why is it that like the Chinese government claims that they have such few influenza deaths out there? Is that a fake statistic, or is it
well, it's like we had a big drop of influenza as soon as we shut down.
Right.
So you're not only stopping coronavirus, you're also stopping influenza by shutting down.
Right.
So I don't know exactly what.
But in general, like in 2018, influenza basically starts in it kind of like starts in China and then spreads out around the globe. But like China claims that they have such few minuscule number of influenza deaths compared to America's, tens of thousands of influenza deaths.
Yeah, I don't know anything about that, but it could be, people could do these kind of things, but I could look into that. I mean, there are ways to look at these things and see if the relationship is correct or not correct. And that's basically, you can actually see if people fake data. So for example, we had data from the pollution in Beijing, and you could tell. We actually did some applied some chaos theory tools to it, and you could see that some of the data was fake because it did some weird shit that it's basically like went it's basically it could look completely unnatural. So you can actually see that when they manipulate the data, it's kind of like obvious with these data analysis tools that they're manipulating the data. But
wow. Oh, so Ayako Fujitani has a couple of questions, but one of them we answered, and you're gonna love it because she wants to know if you can get the virus twice, but it turns out you can get it every year, perhaps.
Yeah,
right.
Maybe. A lot of people have not proven it, but I think we have not had enough time. But from all the other coronaviruses we know, from the other two beta coronaviruses, we know that you can get it again and again.
So you can get it every year. Okay, that's if there's no vaccine.
Yeah.
And I'm laughing. I'm laughing because it's like I thought, oh, you can get it twice. No, you can get it every year.
Yeah.
It's even worse. So okay,
That's
next
probably
question.
going to be like, I mean, it might be
Uh-huh.
that you can only get it every 2 years, but
Oh, damn.
but so far it's like you cannot really
It
know that
sucks.
until it happens, right? So it's
Yeah.
basically it hasn't happened. Our best guess is based on its cousin, right?
Yeah.
These are our best guesses right now.
Her other question is, what? And this might be out of your realm of studies, but it's she asks, what would be our future every day if we never find a vaccine? What's it going to be like?
Well, I think it's like the good thing I think is basically if we get a drug that is orally available that you can actually get tested quickly. Basically, as soon as you get sick, you get the drug, and then it's going to be really like a flu. So I think the best case scenario. So, and it's like if you get it early, probably you can avoid a lot of this immunological consequences that you get late. So basically, like everybody's gonna get a mild infection. So I think it's like basically like as soon as basically people massively produce maybe the Japanese drug Avigan, when you have like tons of that, and maybe a combination of drugs that nothing that you need injected, something you just take orally, like a pill. As soon as you feel something, you get a quick test that tells you within, let's say, minutes or an hour whether you have it. You get the prescription, you take it, you go home, you just sleep it off for the next few days and like that. I think that could be the best case scenario.
And you might have to do that
every case and we're gonna
Yeah.
and we're gonna have this every year, and we're gonna have it every year coming, but we're gonna manage. But I think it's like if you manage it by drugs, I think it's almost as good as having the vaccine. It's like nothing serious will probably happen. It seems like a lot of if you get like a large dose of virus, you seem to do worse. So reducing the virus by drugs or whatever means. That's also why the face mask and everything is important.
So do you think
a low dose, even if you get?
Do you think a face mask will continue then in the next year? Like we're going to be supposedly needing to wear masks?
I think it will probably be my guess.
Or indefinite?
Like 2 years plus at least. We're gonna have face
Oh my God! Yep, there you go. So what about Coachella in October? Last time we canceled Comic-Con ourselves.
EDC
right?
is also canceled.
What's that?
EDC is also canceled.
Oh no! Not
when
Daisy
when's that?
It's June.
When's that?
And
it's June.
Anime Expo is canceled.
Yeah, we canceled Comic-Con ourselves a month ago. We called it. But what about October Coachella? It's October, right?
I think anything big.
Is it better just they haven't canceled it yet, right?
So I have no confidence that the Olympics are going to happen next year.
Wow.
Whoa.
So that means concerts in general, if a no vaccine is found, will there be concerts anymore?
I think it's like I think if we can manage by drugs, and the drugs become widely available, and testing becomes super easy and fast.
You mean testing, like let's say a basketball game, there's 20,000 people are going to watch the Lakers play.
Like say, okay, no, it's like you feel something, you go get tested, and then it's like,
okay,
you can manage, and it's like, but then it's gonna.
I thought you meant they would
be like the flu, sort of.
I thought you meant like a metal detector at a sports event that everyone gets tested before they go in, type of thing.
I don't think that's feasible to test at that massive scale. There's no technology that allows you to detect virus at the sensitivity of like single molecule level that can do that at that speed.
So, for example,
the best case scenario is that you can actually do it in like minutes, not minutes, tens of minutes, not and also it will require you, swabbing and stuff like that. It's not going to be like walk-through type tests. I don't think.
So concerts are done for a while. In general, right? Unless you go to a concert where you're one of 10 people inside of a building.
Yeah, I think it's like I think it's like you saw the thing that Taiwan did, right? With the baseball game, they opened baseball game, and so far it went okay. But Taiwan has been like really at zero pretty much for a local transmission 0, and and they had basically a baseball game with I think like 5,000 people or something like that.
Mm.
But that's a stadium of basically for I think it was like 50,000, and they just kept 5,000 people in.
Oh wow. Yeah, there you go. See,
1/10
so
capacity.
yeah, that's what I was thinking. That the
So
only way you
basically,
could do
like,
it
people
is
separated, everybody wearing masks, and there's like separated, but they were still having a, you know,
so in that case, they would probably, if it's one tenth of the people, they would probably have to raise the price of the ticket 10 times, correct? So you can actually go watch the Lakers instead of $1,000. It's now going to be like a $10,000 ticket or more, right?
maybe if it's
Because there'll be
market
because
forces are going to drive it down,
right,
drive it up, or
because you have less people. You're one in, instead of 20,000, you have 2,000 in Staples Center. They got to make their money back. Oh, what a disaster! It's only going to be for the super wealthy.
Yeah.
Yeah, I think that
Maybe.
it's like it's like the TV rights are going to become more expensive also, and then
Oh wow,
everything is
that
going to be
too.
pay-per-view probably.
Yeah. So one listener or viewer is asking, Andy Shen, who's a doctor himself, asks, "Do you have any opinions about fall school opening? I just joined a task force for school opening for one of the SoCal school districts, and that's September, right, or late August or September."
Yeah, I don't know. It's like that really depends on the thing. All these things I think are super dependent on what is the local what is the local contingency plan? Okay, what do you do if a kid gets infected and starts transmitting? What do you get, like a local
I
cluster?
mean, and it's gonna be like a playground of kids all fucked up, and then a shitload of parents.
No, I think it's like that. I mean,
Forget it.
regardless, I think it's going to be more how they actually bring it home. So the question is like,
Badly.
it's going to be super difficult to have the kids self-discipline. That is, to keep the social distancing in kids is going to be like, I think, nearly impossible, right?
Mm-hmm.
As I see it.
Yeah.
And then it's like, and also like, so basically like this is, okay, what kind of management plans can you actually implement? Are you going to basically, separate the kids and they have to eat at their own spot? You're going to have to reduce the density of students. They have to alternate days or something like that, or alternate times, or they actually, how do you do testing of children if something happens? How do you do contact tracing in the school in order to manage this kind of thing? So I think this is going to be something that LA Unified will have to figure out what a reasonable plan is, if it's doable.
Close the schools. Thank you.
I don't know. Like, I think, like, I mean, there is clearly benefit to having schools. The people
Homeschooling.
Well, homeschooling also has issues of people's, social maturity.
Yeah.
Yeah, it's not going to work.
It's
not going to work.
Humans
No, it's not going to work.
are supposed to interact in order to, develop properly to be, contributing members of society, right? So I think it's like, yeah, it's tough. Like, that's not my area of expertise, so it's like I cannot really speak, but I can only say that it's like, how do what will you need to manage in terms of, you have to have a plan for when things go wrong, and how do you limit the damage when when you have this going. I think it's like, a lot of this is going to be, because this is sort of like uncharted territory for just about everybody.
Yeah.
So a lot of it is going to be like touch and go, try to work out the problems as they show up. And that's basically what you see in Korea and also in Wuhan, where they actually had after not having any cases for, I think, some 20 days, and now suddenly had a cluster of some 40-some-year-old woman who infected 6 people in her own family and in her own building. So, and now they're testing the entire city. I think that's probably overkill. I'm not sure how useful that is, but that's the route that they are trying. So I think it's like different people are going to try different things. Like Sweden is trying its own thing. And like, the question is like, in the end, because it's also not just managing the virus, we also have to manage the economy, as everybody is aware of. We have to manage society as a whole. I don't know exactly what is the best way to go, but I think I think a lot of it is going to be a matter of trying out, see what works. If you see that something is going, you know, going like really, really badly, you really want to pull back and clean up the mess that you made. But you have to have a way to clean up the mess.
Yeah. I've been super disappointed with maybe how Los Angeles, okay, things didn't go as bad, but there's some strange things that have just come out recently, like you're supposed to wear masks now as of Monday. I thought we were supposed to wear masks like a month ago. And then you're supposed to, and you're now supposed to wear a mask on the metro train. Weren't we supposed to do that already? And this was just a new thing saying starting Monday. And I'm like, shouldn't we have done that like a month ago? Or I thought it was. Yeah, that's a new thing. It just came out on Monday. It just said this past Monday, this is now when you start wearing masks. I'm like,
before it was recommended and now it's mandatory.
Well, in San Diego, it was like they were telling people to do it, but it's like the compliance is really poor.
Yeah, in my own area, my neighborhood around here, I would say I feel like it's about 20% of the people wear masks and 80% do not. At least on the streets walking, which is just walking on the street, but it's about 80% not wearing masks.
Like, the risk in and you're walking on the street, I think it's less.
It's less, but I'm just saying
but I think it's like,
yeah.
But if you go into the, if you go to, if you go to Trader Joe's, for example,
that's 100%. It has to be. Everyone has to wear a mask.
Then and Trader Joe's tells you that you should wear a mask.
Sure, but I also think it's weird that they did for a long time they didn't wear masks. Even the employees didn't wear masks, and people and some got sick and fucked up. It was just one of those things that's just like a breakdown of logic, and I've been seeing a lot of that. Unfortunately, it's been almost painful to watch. So I stopped looking at a lot of news and Facebook and stuff like that because of. I'm just watching fails every day.
Yeah, I think it's like a lot of it is that people's, it didn't hit people as being real.
That's their fault.
And it's like, and a lot of
crazy.
Like, I think it's a little bit of this kind of thing because nobody has seen it before, and people are not, people's reaction to things is because if you've never seen it before, because everybody is basing their behaviors on their own past experience.
Well, which is crappy.
This is uncharted territory, right? So like, of course, people are going to be skeptical of it until they see sort of overwhelming evidence or something like that, and they might not like it. I mean, nobody likes the restrictions, right?
Of course not.
Yeah, I'm just wondering, like, what is this doing to Tinder?
People are chatting, I think, a lot on the phone. It's pretty sad. But actually, I wanted to ask about the, their arguments against masks. Carbon dioxide, blah blah blah, make hard to breathe, etc. Like, have you heard of any of these arguments before, and have any thoughts about them?
I've not taken any of those seriously, or there's no real argument against masks that I think is credible. There's like the increase in carbon dioxide is like, is minimal, but of course it's uncomfortable and and it's hard to breathe for sure. You have to push so much harder.
Right.
I don't like to wear masks, but it's like, and also the ones that do the most filtration and when it's working properly, they're going to be harder because you have to push everything through those little pores.
Right.
And it's going to be hard. Right. So it's going to be hard. Like, you can see, I saw some interviews of the Italian healthcare workers, and they have to wear it all day and they are tired from wearing the mask and stuff like that. So I mean, nobody likes it,
right?
But I don't think there are any, it's not detrimental to your health. You cannot make that argument.
Yeah, I think there was a woman making an argument at a Trader Joe's, and she posted a video of her going, blah blah blah, carbon dioxide.
Oh, it sounds like a Karen. They call those Karens.
Yeah, it was a Karen. Freaking was like, like, I want to talk to the manager, about because they were kicking her out because she wasn't wearing a mask.
Wow.
And apparently she posted the video and like basically made herself look like an ass.
Oh,
How
wow.
about these like cottony kind of masks? Like, like are these like good enough to
Looks
like go walk around in? Or is this kind of a waste of
that looks
time?
like a little bit of an underwear right
Yeah,
there.
it's like a fucking like I usually like rest
That's a
my
ball
dick
sack.
on it.
That's a ball sack sling. Ball sack sling.
Yeah. How about this ball sack sack sling? Is this
Yeah, it's
I don't
hard to
know.
say.
Like the
Tongue
thing, like
twister.
I mean, each
I'm-
type of there's a nice there was a nice New York Times article that actually went to somebody, I think at Emory University, who tested a whole bunch of common materials and,
Uh,
and tested like how well each of those things work.
we looked at that. Or I looked at that
Yeah, I think I sent
article.
it to
Yeah.
you.
Yeah, I looked at that. But basically, a thin T-shirt is like 20%
Right.
protection.
So this
Like
is
a
for
thinner.
2 t-shirts. So
Yeah, so maybe it's 40 or 50%, maybe literally. 40, 50%.
right.
That can hold my ball sack, by the way.
Yeah, it probably could.
Oh, I have this one.
Oh, the GR mask. So that one's got like the baby clothes outside, but it has a 1,000. I think it's 1,000 count
Right.
fabric on the inside, and there's 2 layers. So that's a 3-layered one, and it has what do you call it? A pocket that you could add your own
You
filter.
can add your
So you could make it as more COVID proof possible
yeah, you
as
can
you
get
want.
a PM 2.5 filter into it, and the PM 2.5 is basically what your surgical mask is.
Okay.
So you
And
can
then
you can get all that.
You'll notice it because it's actually hard to breathe.
Yeah, because I added like a coffee filter in it, and I did 2 coffee filters, and you know what I mean. Added more stuff to it, and it just gets harder and harder to breathe.
Yeah,
That's the issue.
you
But
actually have to have to a way that there
So
are. Yeah.
yeah, so with these masks,
that's a surgical mask, right?
yeah, I got this from my dentist. Like how can there's a lot of them on the streets right now.
Mhm.
Like is there is there a way to tell the difference between good ones and not so good ones?
It's really hard. It's like, I mean, normally you go by the label, so that's the thing, because there's very difficult for you to test it. But you're gonna know is like if you actually breathe on it, you're gonna have a little bit more difficulty. You know that's filtering more.
Because it just seems that it's funny in our age, our time, bootlegs are just so common now that you don't know what's a real N95 mask or a fake one just by label. That's the most bootleg thing, right? It's so
Yeah.
simple.
Yeah,
Like-
because the way that you actually test it is like nobody has the capacity to test that at home.
Right.
Mhm.
So that's like the thing.
Have you tested any masks yet?
Hmm?
Have you tested any masks at your lab? I know you can do that.
No, we actually don't even have the proper equipment. We're like a molecular
Oh.
biology,
I see.
lab, and we don't actually have this physical particle. I mean, you
Mhm.
probably need to have the best way to test this kind of. There are ghetto ways to test it. The ghetto
Okay.
way to test it is basically
Get a took.
it's basically like let's say you have your mouth bacteria or whatever else, and then like you take the mask and then cough on a petri dish and then see how much gets there.
Oh wow.
So
Wow.
and then there's that is sort of a ghetto way to.
Do you know what I really like is when you're wearing a mask for a while and you take it off and you have the incredible sense of smell for a little while, like you know what I mean? You could smell better. Right when you take off the mask, you're like, you could smell things. You're like, holy shit. And then it goes away and like, 10 seconds later, you're like, I don't smell that anymore.
Yeah, you're desensitized to the only smells that you have in there, which is for your own breath.
Yeah.
and then it's basically
amazing.
like you're sensitive to everything else.
Yeah. It's an amazing sensation that when you remove your mask, you're just like, holy shit.
Yeah.
And then it goes, yeah.
Like at work is great.
I dig that.
There's like we had well, not now because they're already gone, but when the first thing started is like we had these orange blossoms, and then it's basically at night when the when the jasmine kind of smell comes out.
Mm.
You're like, whoa, this smells so good.
Right. Yeah.
So I asked you this last podcast, last time we talked. Are we going to be okay?
I think
you had
as a whole, we're gonna be okay, Eric. We're gonna be okay, but I think less okay than before for a while.
Yeah. It's not like I mean, like yeah, this virus is killing people, but it's not like the I mean, the numbers are really quite small in comparison to the potential of this
Yeah,
virus.
in comparison to the whole population, if we actually had a, let's say we actually had a MERS type thing, or a real, like the original SARS that was just transmissible like this one is,
Mm.
you would actually looking at, you'd be losing like 10 to 30% of the population.
Wow.
And that would be like, then maybe say that you would actually have people dead on the streets, that you could not have that, you know, the the crematorium to take care of the people in time.
You
The
just have
funerary home
big
would not, yeah.
pits, big
But
old pits.
there's like the thing is, like in certain places in Spain, they reach these kind of levels.
Mm.
You know, they, for example, in Madrid, it was like the Spanish army was going into basically retirement homes and finding dead people in every other room, kind of like that. And because of the staff also got infected, so they short staffed, they couldn't take care of people, so the combination of things ended up being like that for a while. So
Mm.
Well, can you hurry up and save us?
we'll
Save us,
try.
please.
Well, we'll try, but it's like there are many things that are being done. I think they're like, especially the,
Yeah, but I know you. Those other ones. Who are they? I don't believe them.
well, like one of them is just my neighbor up the street.
Yeah, that one's okay. I'll give them a pass.
So
And
he found 30 drugs.
The Japanese one, okay, I'm down.
He found
But-
already 30 drugs that can be tried now.
But
30.
but okay.
He's got a whole bunch of other ones, but they have to go one by one and figure out which ones they're gonna try.
All right,
They're,
try them
they're-
all.
They're trying in Hong Kong University again to see which ones. These are also all the clinically approved drugs, so it's just a matter of testing.
Right on.
Yeah.
So where do we go from here, Gerald?
Well, we'll see how we reopen. I think that's the next big unknown.
Are you hopeful, or are you looking at it thinking, okay, I already know what's going to happen?
Well, I think it's gonna be messy. It's gonna be very. It's gonna be. It's gonna. The U.S. is gonna be like.
It's gonna be a shit fest out here, man.
Yeah,
But where's it going to go wrong? Do you think is it going to be in the South where we're already seeing more? I mean,
I think
yeah.
like people have to realize when it's. I think it's like. I think like most people, they don't have a sense for it to be real until they see it themselves.
Right, but like, is it going to be?
When you start seeing like the ambulance coming to your neighborhood, and then picking up people in stretchers, and then you see enough of those, I think that's going to make an impression. And then
so that was like maybe New York kind of had that experience a little bit, right?
yeah, I think it's like I think, I hope not, but my understanding of human nature is that basically it's going to require some kind of level like that. But by then it's like it's going to be such a mess. It's like that's going to impact the economy in itself. So the difficulty is basically like, the economy in the bigger sense is also about trust, right? So I trust that the goods that you sell me are going to be something that I want, that you're not trying to rip me off, that there's going to be an interaction of some sort. But if you actually basically decimate the entire economy, pepper across, you're going to end up being this can be like a real thing. Like, I mean, if we just think of it right now, we're kind of okay because all our supply chains were kind of preserved, right?
Right.
But if our supply chains are going to be disrupted,
and we're also still early, right? They're able to. I mean, they're still able to like support unemployment, and there's all these things happening. But this is just the beginning, isn't it? I mean, 6 months later or 3 months even from now is the bigger question mark. I think.
I was just hoping that we would, I was just hoping that we would actually have something like South Korea, or, I mean, Taiwan managed it so well they never got to the stage that that they have like the
we can't do that
kind of thing.
Oh, we can't do that here.
Yeah, we cannot do this
I
because
no.
we have a completely non-compliant population, and
Yeah.
people, then there's and then we don't have a competent unifying government that can pull it all together and have a unified response for the entire country. And you have
Or unified media either, which is the tragic one of the rougher parts about all of this. We have too many different news outlets that are spreading.
It's basically the thing is like, if I mean I'm trained in this area, and I know, okay, I look at this thing, oh, okay, this is not believable, this is believable, and like that. But like I have like 30 years of training plus of this, in this area. So but I mean, what is gonna average person gonna think? Like, what do I believe? What do I not believe? It's basically you're just paralyzed by all these different things that you actually have, and it's like, how?
That's why we're talking to you, man.
Yeah.
So,
That is why we're talking to you, because you are a man of science.
Yeah. Man of science.
Science.
Who's handled the virus in his own hand.
That's true.
yeah.
It was in your hand.
Yep. In a dish or whatever. You
Yeah.
handled it.
Yeah.
I have never even been that close to it, I don't think. So
Or surprisingly, maybe we have. We just didn't know.
You doesn't know.
no.
But
Yeah.
as long as you wash your hands and keep, and basically just, do you guys watch that NHK documentary with the dye?
I watched it.
Yeah.
Yes.
Yeah.
So that is basically, think of it that way. I think that's the safest.
I don't think enough people watch that. They need to make an American version with dubbed.
Even
maybe
though
dubbed.
It's all in English.
They need to dub it. They have one super dubbed.
Well, the one that I saw that
was it dubbed?
Yeah, it was dubbed.
Oh no, they need to they need to remake
like
it.
Maybe one or two voices. Like
They need to South Park it. Like they need to go that route.
They didn't make an anime version of it.
Yeah.
No, but I mean, this like, so when we were trained for biosafety level 3, I mean, that's basically how they teach you how to handle everything. So anything that you touch, anything like that you touch has to be disinfected. This is the way you have to operate in order to work in biosafety level 3. So you assume everything. So for me for everyday thing is basically, I just took my training of biosafety level 3 and sterile technique, and I'm sort of applying to everyday kind of things instead of just applying in the lab. Because in the lab is basically, you go into this lab, you gown up and you get this thing and you do the thing, and then after you get out, you don't have to follow these rules anymore. But now it's like, in this situation, it's like I'm taking my training and then taking it out of the lab into my everyday life.
So when you buy groceries, are you actually going into the store with a mask? Are you doing that whole thing, or are you getting curbside?
I'm going into the store wearing a mask. When I get back to my car, I take the disinfectant wipe from the trunk, clean my hands again. The trunk handle with the lock, basically the door handle of the car before I get back into the car, for example.
So, do you recommend people do that? Because I don't even go that. I think
it's like, so basically, like, the virus itself like seems to be on most surfaces. In 3 days it'll be gone. So if you were to, let's say, if you have things that you can, I wipe things down with chlorhexidine wipes.
What's that?
You can use, like, it's just a disinfectant, but you can use anything else.
But I mean, saying like
alcohol wipe or something.
If you buy groceries, you're touching boxes of shit, boxes of stuff.
Yeah, you're touching it, but it's like, but by the time you get back to your car, you wipe your hands again with it.
Then you go back home and you put it away. You're back at square one, right?
No. Like, so you take the stuff, like the groceries that you take in. I mean, I do it, but it's like, you don't have to. I think the risk is low, actually.
But it's okay. What do you do? I want to know what I want to know level 3 technique.
So when I take it home, I take the stuff. I wipe the outside of with the wipe and then put it
everything. Fuck. Okay.
I don't even do that.
I mean, I think the risk is low. It's like, the question is like, how much risk are you willing to take?
None, but I don't do that. But now I need to.
I mean, the only thing I
Right,
ever do is wash my hands like before I get in the car, or after I drop everything off.
Yeah. So for example, when I go outside or the grocery store and come back home, I also take a shower before after I get home.
Do you like then you wash your clothes or you put it in the dirty laundry right
Or
away?
day their laundry and
Right?
all that. Yeah.
Wow. Okay. I was kind of doing that in the beginning, and I kind of tapered off. Is that a
Yeah, I mean,
mistake?
it's really hard to keep up these kind of routines
It's
because they're
it's
like
tough because sometimes I
they're
forget.
like they're tiring and they're a hassle. I mean,
I think the other day, it's like I just kind of forget, and I'm like, oh no, I didn't even think about it, but I'm trying anyway.
Yeah.
But okay,
All right.
that's level 3 technique.
There it is.
Yes. Anyways, I think our time is kind of
Yeah.
up,
We're
but
there. Gerald,
yeah.
thank you so much.
Yes,
again for
thank you so much.
Your time.
Oh, you're welcome. Good talking to you guys again.
It's always
Yeah,
very
no.
educational. Like, I trust in your information. So you could like
Thank you.
feed me big fat lines of bullshit and I'll be eating it up.
No, my line is like I don't want to bullshit anybody.
So, but I thank you. Thank you. It's always
You're very welcome.
enlightening talking to you.
I like your background, Luke.
Oh, thank you. I am in my Animal Crossing background right now.
I've never played that, but I hear everybody's playing this nowadays.
I am playing. I am deep in the game right now. Well, not
You
right
play,
now.
Eric?
No, I don't.
Do you have it?
I don't have it.
I have it. It's got it right here.
Is it a Switch game?
Yeah, it's a Switch game.
Oh, okay.
So
I should
that
get one of
is-
those. I don't even have a Switch.
My friends in Japan said that they couldn't get the Nintendo Switch because like
Yeah.
so heavily ordered that.
Wow. Yeah. Well, it's an item that you need now. You can visit your friends without
Oh
you
yeah.
can visit your friends' worlds, I guess, without physically
Yeah,
being there, right?
That's
So what do you do at Animal
It's a
Crossing?
virtual game.
you
Wait,
build
I-
up
wait.
an island and you like
I'm gonna stop. I'm gonna stop our podcast now. Is
Okay.
that cool?
Okay.
All right. But then we could keep talking about it.
Okay,
Okay, yes. No, it's
everyone.
yeah. You basically like you have a little island.